Today, I'll be going through Maris Stella High School Primary P6. This is their Term 1, the first WA last year paper, and this is just focusing on question number 18. This is related to force. Okay, force. Okay, so over here, we have a diagram that shows the block that's attached to the string. So the block, right, is actually pulling. Okay, pulling it down, and the spring is being extended. Okay, the spring is being extended. Okay, on the block below, draw two arrows from the dots. Okay, to show the two forces that are acting on the block. Name the forces next to the arrow. Okay, so for this, right, generally there's two forces. The first one will be your elastic spring force. Definitely. The other forces is actually the weight of the block, commonly known as your gravitational force. So over here, right, the gravitational force is always a downward arrow, pulling it down. So you can write this gravitational force. Okay. The other force will be your elastic spring force. The elastic spring force, it is pulling up. Okay, up. Okay, because the elastic spring force itself, elastic spring force, let me write this down, is a force is a force acting on the object by the spring. Okay, so when the elastic spring force is being stretched or extended, right, it itself will want to return to its original length. Okay, to do this, the spring will want to stretch back, so that will be the direction of elastic spring force. Okay, but for this, right, if we were to consider a different scenario, if a spring itself, okay, this is a spring, but I have a block on top. Okay, I have a block on top. Okay, then the elastic spring force will be in an upward direction, because the spring is now being compressed. Okay, this is elastic spring force. Okay, and the direction will be upward in this case, because the spring is being compressed. Okay, in this sense. Okay, so different scenario, the direction may be slightly a bit different, but for these two, they are kind of the same. Okay, depending on the scenario. Okay, let's move on to the next part. Anu and Ben conduct their own experiment, okay, by measuring the length of the spring as they increase the mass of the block hung on spring. They use different spring for their experiment. The table below shows their result. So you have Anu result. You can see as Anu increased the length of the block, it increased the mass of the block. The length of the spring remained the same. But for Ben, when he increased the block, the length of the spring increases. So based on Ben's result, what is the relationship between the mass of the block hung on the spring versus the length of the spring itself? Okay, so this one is a very, very direct question. As the mass of the block hung on the spring increases, the length of spring increases. Okay, so this is related to Ben's result. So give a possible reason for Anu's result. Okay, how come whenever he increased the mass of the block, the length of the spring remain the same? Okay, it shows you one thing. The spring, right? The spring did not extend. Even when more mass are added to the spring. Okay, how come the spring did not extend? only one reason: too stiff. Okay, that means if I use maybe the Anu, right, when he used 150, right, it is not enough to stretch or extend the spring. He might need to use maybe 300 or even close to 400 to be able to stretch or extend the spring to maybe 11 or 12 cm. So that is only the possible explanation. The Anu spring, right, is too stiff, but okay, but for Ben, right, it's less stiff. Okay, it's easily compressed or easily stretched, or extended. Okay. Okay, so this is the reason for Anu's result. And you can see the spring is too stiff to be stretched. Okay, that will be good enough. Okay, for this case. Okay, that will be the end of this practice. So let me just zoom in out. Okay, okay, that's all. Thank you.